10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Hello everyone. Hope you all are doing great and staying safe at your end. Welcome to the day one of pre-hackathon speaker session at Hack This Fall. At Hack This Fall, we will be hosting lots of live workshops, talks and discussions, which starts from today itself and will end on 30th of October. You can check out our website for further details, a complete schedule, and to know more about our speakers. Talking about the today's speaker session, notebooks are very awesome. Perhaps you have used them in your classrooms, but one problem is still there, that there are so many of them. Just at Google, we have Colab, cloud AI platform, notebooks, and Kaggle Kernels. Several major cloud providers offer notebook services, and then there are open source efforts like Binder, Jupyter Hub, and a whole ecosystem of tooling. So, which you should use? The answer, as usual, is it depends. This session will summarize your options and try to help you choose the best notebook service and tools for your needs. And with that being said, let me introduce you all to our speaker for the session, Marc Cohen. So we have Marc Cohen joining us. Marc is an American software engineer working on Google's developer relations team in London. His mission is building tools, demos, tutorials, and other educational artifacts to make computing and data science more accessible and inclusive. Before joining Google, he spent 30 years building products and managing engineering teams in the telecom industries like Bell Labs, AT&T, Lucent Technologies, and so many. We welcome you, Marc, and look forward to your talk. The virtual stage is all yours today. Thank you.
Thank you so much, Tirthak. It's nice to be here. Thank you for joining this live stream. As Tirthak's indicated, I'm going to talk about notebooks today. I happen to love notebooks because I love education. I've always loved learning and teaching, and I feel that notebooks give us a new tool which we haven't had in the past, which makes the learning experience more interactive. And I'll show you a bunch of examples of that today. Before I get started, you can see my blog, my Twitter, etc. And all of the slides that I share with you today are available at this URL you see in the lower left, mco.fyi/nb for notebook. I also love puzzles, so I've just, apropos nothing, I've included a little puzzle here on the right-hand side of the screen. And for those of you who are like-minded, I'll warn you that the answer that seems most obvious is not the correct answer. So feel free to have fun with that. Hopefully after my talk, but I know sometimes you just can't resist a good puzzle. So let's jump right in. What's more exciting than artificial intelligence? It's hard to think of anything nowadays that beats that topic, but I would argue human intelligence. I personally think the AI revolution is fascinating. It brings with it some incredible innovation, but it also brings with it some new challenges in terms of responsibility and policy and things of that nature. But personally, I get even more excited about using technology to enhance how people can learn new things and learn more effectively. So we'll basically talk about this tool I've been alluding to called Jupyter. And I'll go over 3 examples of Jupyter notebooks that you can use in the Google Cloud, and we'll finish up with a bit of guidance. So I assume many of you have used this tool, and so I apologize if this is repetitive or something you already know quite well. But just to make sure for people who haven't used it, that we're all on the same page, I wanted to just share a quick description of what Jupyter is all about. So Jupyter is an interactive tool. As I mentioned, it's a learning tool. So it's really about trying to understand things in the world, although it can be used in other ways as well. It's based on an open source software product called Jupyter. And the idea behind it is that you kind of manipulate a document, and the document has both text cells and code cells, where the text is written in this very nice kind of markdown syntax, and you kind of get an immediate feedback on what the rendering of that markdown looks like. And then you also have code cells, which are literally interactive, executable chunks of code. One really valuable thing that I find about this environment is that it's got a unified user interface. And by that, I mean both the authors of the notebook and the consumers of the notebook see the exact same interface. So unlike other tools where you kind of go through a portal and you have a somewhat different experience to create the tool from the actual consumer of the tool, it's pretty much the same one unified interface, which makes it easier to deal with, I find. So the first type, oh, and by the way, I'm happy to take questions as I go along. Put something in the comments. If you have questions for me, I'll try to keep on top of it, and I'll leave a little bit of time at the end for Q&A as well. Okay, so the first type of notebook I want to tell you about is called Collab. And the way I would characterize this is it's a free, zero friction notebook, which is built on Google Docs or Google Drive, technically. I've pictured a classroom here because I find this to be the most compelling and obvious application of Collab. But there's lots of ways you can play with it and lots of benefits you can get from it. So I'll walk through some of those. And actually, before we talk about the strengths and the weaknesses, I want to actually show you a couple examples. So I've been teaching a kind of home designed Python programming course. And if you're interested in this, I offer it periodically, not to be too much of an overt plug, but I do offer this periodically. And all of the materials are available online as a self-study kind of course. So if you go to my blog, mco.dev, you can find out more about it. It's pinned at the top there. Anyway, I am using Colab Notebooks exclusively for this course. It's not really about the cloud, although there is a cloud unit. It's really just about teaching beginner programmers Python. And so I'll show you just some of the examples of how I've done this. I have some text here, which is giving you a rough idea of what you can expect in this lesson. I have some preliminary items, and then we dive into some topics like functions. And so this is a text cell, which I've done with Markdown. I can say functions are, I'll change that to say flexible building blocks. And I haven't even saved anything, and you can see the rendering on the right has been updated. Actually, let me make this bigger for all of you. The rendering is automatically kept in sync with my typing in that cell. And then if I just double click to change it, it's saved, and I can save it in Drive. Unlike the rest of Google Drive where, like in Google Docs, you just type and it's automatically saved. This one's a little bit different. So you do need to explicitly save things in this interface. And that's probably for good reason, because this is sort of like a code, more like source code than a document. And so you want to test it and make sure it's working before you save a new version of it. But the really fun part is when you get into actual code snippets. And so, you can essentially put any Python text you want, any Python syntax into one of these code cells, and you'll be able to run it. And what's happening under the covers is there's a server process behind this user interface, which is able to run snippets of Python and keep a state around for your notebook. And so when I run a snippet of code, this one doesn't, it defines a function that does something trivial, so it doesn't show any interesting output. But the notebook is gathering this snippet of Python code, sending it to the server that's backing up this notebook. The server runs it sort of by proxy and returns the result to the notebook, and then the notebook user interface displays the results. Maybe I can show you one where it actually does something. Yeah, so here I'm defining a factorial function, and then I'm calling it. It's a factorial of 10. And then I call the function and it returns the result. And obviously you would not typically define a function to compute the factorial of one specific number because it's kind of a niche request. And this was my way of motivating function parameters or arguments. And so, you know, you go from fact 10 to fact where you pass the number as an argument, and then you can call fact of anything. So just find this a super nice way to teach, because I can present the concepts, talk about it a little bit, and then show the students the code. And I typically invite them as soon as they come to my class to make a copy of the notebook. And that's easily done with File, Save a Copy, and Drive. You can also save a copy in GitHub. In Collab as well, you can open a notebook from Google Drive, GitHub, or you can even upload an IPYNB file. That's the standard file extension and syntax for Jupyter Notebooks. So you can import a notebook by simply uploading it to Collab. So yeah, students will typically make a copy of my notebooks, and then they will kind of follow along as we're teaching. And I invite them to experiment, play around with the code. Once you've got your own copy, you can open a cell and you can, you know, change it any way you want, run it, see what happens. It's a nice kind of experimental environment to work in. One other thing I find really works well here is homework assignments. So here I challenge you to write a function called total that returns the sum of a range of integers. And I give you a starter version of that function, which does a horrible job. It returns 0 every time you call it. And then I have a cell that tests your function. And this one fails the test. Well, it says total is not defined. Let me define total. And then run the test cell. And test 0 failed because it should have added up to 15, and it returned what my version always returns, which is 0. And so you're invited to change this return 0 to some more reasonable code to complete this task. And once you're done running the testing cell, you'll see an all tests passed print message. And so makes it easy for me to challenge people with little exercises like this in the notebook. So that's a quick overview of what Collab is all about. Actually, let me show you one more notebook, because this one I think will give you even a better sense of some cool things you can do with Collab. So I have a lab I give where I teach a little bit about machine learning using TensorFlow and Keras, and I kind of walk the class through an interactive exercise of building a machine learning model. So typically I install TensorFlow, and this illustrates that you can access shell commands or system commands by just prefixing them with the exclamation point. I think that's a feature of Jupyter in general, but it works just fine on Collab. So I'm able to pip install, which is the Python installation utility, the TensorFlow package here, and import a bunch of dependencies. I set some parameters, and the exercise that we're working with here is the MNIST dataset, which is a bunch of handwritten digits that derives from many years ago. The US Postal Service wanted to automate their ability to route paper mail based on what we call the zip code in the US, or the postcode it's called here in the UK. And that routing process can benefit obviously by automation. And so there was a great deal of interest in those days on being able to look at a handwritten digit or a string of digits and turn it into the digital equivalent. And so we use this data set in this notebook. I'm going to run through a bunch of utility functions. Normally I would explain these, but today's talk is not really about this notebook per se. It's sort of meta talk about notebooks. So you can feel free to come visit this notebook and actually look at it more closely, try out the exercise. I didn't mention this, but it's available at a nice short link, mco.fyi/mllab. That's 2L, MLLAB. It's in the slides, so you don't actually need to copy that down right now.
Hello, Mark. I think he has got some issues with the internet connectivity. We'll wait for a few minutes. So I hope all of you guys are enjoying the session. We have still not covered some of the core portions, and it will be very enjoyable ahead. The interaction between the audience, that is you and Mark, will be really very fruitful. If you want to ask any question about Google Cloud or about the Jupyter Notebooks or any kind of other stuff, you feel free to do so in the comment section, please. Please stay tuned. Mark will be on its way as soon as he gets his internet connectivity stable.
Terthak, I'm back.
Hi. So is it now okay to continue with that session?
I hope so. I'm tethered to my phone because my ISP is apparently having major problems today. So I will do my best. I don't know if how great it'll be with the 4G, but I'm happy to just jump back in and do my best. Sorry about
No
that.
worries at all. You may continue with this session. It will be completely fine. If it gets stuck again, we can do something even better. No
Okay.
problem.
Thanks. Sorry about that, folks. I hope everyone can see and hear me. My internet service provider is apparently having, let me share the screen, is having a problem today. I got a hint of this when I got dropped a minute or two before the start of this talk, and in a panic managed to get back online, but then it gave out in the middle of the talk. So apologize for that. I'm tethered to my phone right now, so I hope the performance is sufficient, and I apologize again for the delay. So I was just showing you my Colab notebook that I use to show off machine learning model, and I'm going to jump back to my slides. I'll go into presentation mode, and I'll just summarize some of the features of Colab. It's hosted by Google, and so sometimes you'll see folks will want to deploy this on their own, and they'll be faced with the prospect of doing some administration and installing Jupyter Hub or something like that. And this sort of makes all that administration go away. It's just there, and it just works like Google Docs. It's minimum friction. So if you're wanting to teach people, you just give them a link and off they go with any browser. So that's quite nice. I mentioned already it's docs-like. The way you share a tutorial or a notebook is with a share button that looks exactly the same as it does with Drive and Docs. You get the similar collaboration capabilities with Docs. You can, I mentioned this already, load and save to Drive or GitHub or a local file. And you actually get direct access to GPUs and other sorts of mathematical accelerators like TPUs and K80s and so on. There's something called Collab Pro, and the reason there's a separation there is that because Collab is free, it's performance limited, meaning if you sort of overuse it, so to speak, meaning you use it above and beyond what might be considered an average usage pattern, it will tend to degrade its response time in order to give everyone a fair share at the computing resources underlying the notebook. If you would like a more sort of a higher level of service, for I think about $10 per month, you can subscribe to Collab Pro, which gives you bigger amount of twice the amount of CPU, more memory, more disk. It's limited to the US for now, but we're trying to roll it out to other parts of the world. And you get priority access to some of the hardware accelerators. So as I said, the cost is totally free for the basic service and $10 a month for Collab Pro. And just to touch on some of the limitations, where you might run into constraints if you're trying to use Collab. As I mentioned, it's got resource limits, and there's a link where you can read all the fine print on that. But the bottom line is we try to do fair share scheduling of computing resources so that you can't sort of hog the resources from the rest of the user community. The server will stay up for 12 hours, but then eventually you'll have to kind of refresh things. And so the typical scenario is you'll go into a notebook and, excuse me one sec. And you'll run a cell expecting the state to be the way you left it, and it will fail. And that's because the backend restarted, and you kind of have to go back and redo the cells up to that point. And that's actually just a property of Jupyter in general, but it's a function, the frequency of when you encounter that is a function of the lifetime of the server behind the notebook. Collab is Python only, and in fact, Python 3 only. So if you're an R person or Julia or one of those other languages, one of the many languages that Jupyter supports, you won't be able to use it here. It's really also recommended from a resource utilization point of view that you close tabs when you're done and you unconfigure GPUs and TPUs if they're not needed. So those are just 2 user tips if you want to make the most out of Collab. Really great for casual use, for weekend projects. Whenever I want to do something around like how does Python work in this area, or how does this new library work? And I want to just kind of prototype something, do some experimentation, or teach or learn. I find this to be a great option. The next type of notebook I wanted to tell you about is Kaggle Notebooks. So for those of you who've used Kaggle, it's a machine learning community. And really, its strength is that it has that focus. And I should say, rather than machine learning, I should say data science. So all forms of data science, including machine learning. But you'll see people using all kinds of algorithms to either do predictive analytics or get insight out of numbers, doing statistical analysis, data visualizations. It's really for people who want to use data to solve problems. The thing that made Kaggle, kind of put them on the map, and I should mention Kaggle is now a part of Google. It's been for a while. But the thing that really put Kaggle on the map was these competitions that they run, where they'll have an open-ended challenge. People will either as individuals or as teams will apply to compete in the challenge by submitting their model on some test data that Kaggle will run against your model. I made that sound like you submit the test data. You submit the model. You do get a test data set, but you ultimately just submit the model, and Kaggle runs your model against two different slices of test data. One is sort of like the public data set, and the other is the private data set. And then they have a leaderboard, and it's a proper competition, and they've actually had some very lucrative prizes in some of these competitions, which have made some buzz in the industry. It's just a great place to learn. Again, I always turn to education as kind of what I focus on, and it's a great place to learn. You can go and see, how did this team or this person win this competition? What did they do? You'll find commentary, you'll find examples, you'll find notebooks, and those are a great way to learn. Here's a couple of quick examples. The Traveling Santa problem is a notebook that talks about the traveling salesperson problem, which is sort of a famous optimization problem in computer science history. Considered NP hard or NP complete. So it's very difficult to solve a large instance of this problem in a computationally efficient way. And this walks you through some approaches with lots of kind of code examples and visualizations, and just a really fun notebook. And I think it really gives very good insight into the nature of this fundamental problem in computer science. Another thing I found is Kaggle notebooks, unlike Collabs, which are just unbounded and not indexed in any significant way. I mean, they're indexed for your own user profile, but you can't just like search and say, show me every. Well, I'm not actually sure I should say it this way, because you can search all your documents and any documents that are shared with you. But with Kaggle, you can actually get a sense of the highest rated documents and the most viewed notebooks. That's probably the thing I should be emphasizing. And so I went to Kaggle and I looked for the highest rated notebook I could find. And I found this comprehensive data exploration with Python notebook. And if you look through this, it's quite substantial. It has all these sections walking you through the different parts of the data science problem sort of pipeline. And it's very instructive. It's almost like a textbook, but it's an online version of a textbook. So you can try all these examples yourself. And I think it's quite nice. And it's a great example of how this stuff fits into helping people learn more effectively. Some of the features you get are the integration with competitions, but Kaggle also has quite an extensive list of data sets. So if you're looking to do some data analysis, you may be able to find something handy there. There are pre-made courses on Kaggle, and it's got some really nice integration with Google Cloud. If you're familiar with BigQuery, you can access BigQuery from within a Kaggle notebook. You can with Colab as well, but the level of integration is a little bit tighter with Kaggle. You also get GPU and TPU access. And here are just a couple of courses that actually one course I recommend, Intro to SQL. Take a look at that because it teaches not only SQL, but integration with BigQuery. So it's a nice way to see how you can use Kaggle with a very powerful cloud-based data warehouse. And then they have something called Kaggle in Class, which is competitions designed specifically for students. The cost is my favorite price, which is free. So like Collab, you don't have to pay anything at all to take advantage of this environment. There's a fixed resource behind your notebook. You can't actually fine tune that. It has a fixed server lifetime, just like with Collab being 12 hours. This one's 9 hours. And if you're idle, don't do anything in your notebook, your server will time out in 60 minutes. So just like Collab, you kind of get a reasonable, not huge, but reasonable starter allotment of resources that are fixed. And there's no real flexibility in being able to upgrade that. And so, but usually for not really intense applications, usually this is good enough to do some nice experimentation and even compete in some competitions. This is great for the specific domain of data science, including machine learning and AI. The competitions are fun. That you can run a hackathon around this sort of framework very nicely, and it's also a great way to learn more from some of the best machine learning and data science experts in the industry. So I highly recommend going there, getting a login on Kaggle, and taking a look at both the data sets that are available, the notebooks, the competitions, and see what you can learn as a resource. The third and final type of notebook I wanted to tell you about is called AI Platform Notebooks. And if you click on this link manifesto, you'll see some of the thinking that went into this. AI Platform Notebook is a Jupyter environment that's integrated into Google Cloud. And so this is sort of the high end of Jupyter Notebooks. And I'll show you quickly what this looks like. If you've ever used Google Cloud, you probably know about the console, which looks like this. Over here, this menu gives you access to all of the cloud services. And I have a separate talk about kind of a guided tour of all these cloud services. So if I can help anyone with that, let me know. But at any rate, I'm in one particular service called AI Platform. I've selected my project, which is MCO Notebooks. And basically, this is meant to be a kind of headquarters for all of your AI work in the cloud. So you've got a dashboard that I'm looking at right now. You've got AI Hub, which is a navigation tool and a discovery tool for finding other notebooks, models, TensorFlow models, all kinds of resources, data sets. So in a sense, it's a little bit like Kaggle in terms of giving you all the access to all these resources, but this one's sort of built right into Google Cloud. We have data labeling capabilities, pipeline. You can build machine learning pipelines. You can upload models into this AI Hub and have them trained and or served in the Google Cloud. So that's good to know about. But the specific piece I'm wanting to show you today is notebooks. So these are called AI Platform Notebooks. And to create them, you say new instance, and you can pick from a bunch of different types. So unlike Collab, which is limited to Python. And I didn't mention this, but I think they're adding R support. And I'm not quite sure about the language span for Kaggle, but I think it might already be Python and R, but I'll have to check on that. For these notebooks, you get all kinds of options for configuring things. You have R available, Python 2, Python 3, PyTorch, XGBoost, all this sort of stuff. And if you do select a particular flavor of notebook, like let's say Enterprise, TensorFlow Enterprise 2.3, you can say whether you want it with a particular GPU or without. I'm going to say without GPUs, and then look at all the configuration options you get. You can specify where you want this service to reside, which global region and zone. And if you go into advanced options, let me blow this up a little bit for you. You can specify the operating system for that are supported for this one, and the operating system will vary for which environment you choose. You can set up a script to run after the machine is instantiated, and most useful here is all these different machine configurations you can choose from, including compute optimized, memory optimized, etc. What kind of hard drives you want, what kind of GPUs you want, all kinds of degrees of freedom here, which is really nice because now you're moving from this world where you kind of get some service, it's probably pretty basic and you can't tweak it, to an environment where you can nail down exactly what resources you need in order to make your notebook environment run the way you need it to run. I think there's a way to even specify a Docker container image to customize the environment even further. I might have to check on that. But so there's a lot of flexibility and customization features here. And it estimates so the sort of thing to keep in mind here is the reason, one thing that comes hand in hand with having all of these degrees of freedom is that you're paying for something now, whereas the resources were free in the other examples. And this gives you an estimate based on the configurations you've selected, how much it'll cost, which is $103 monthly. I'll just show you what this looks like to actually run a notebook. It takes a couple minutes, maybe three to 5 minutes to create one of these. So I'm not going to have you wait while I do it. But once you create one of these instances, you get this Open Jupyter Lab button. And so the kind of default unit of interaction here is, rather than it being a single notebook like it is with Colab and Kaggle, it's a sort of a meta environment, which is using open source kind of IDE for notebooks called Jupyter Lab. And Jupyter Lab gives you the ability to, like any IDE, open new notebooks, load notebooks that are existing, upload them, interact with the notebooks, get an interactive terminal, all sorts of things you can do here. One thing I really like about this is it has built-in Git integration. And so I can do things like diff my notebook against what's currently checked into a repo, and I can do commits right from this interface, and I can push changes, push commits to a GitHub repo. So it really feels more like I'm working with source code than with a notebook, and really feels like it's sort of an engineering, bringing notebooks to more of an engineering kind of environment. Let's go back to the slides because I think I'm running a little bit short on time. There's a code lab I want you to take a look at if you're interested in this, which will walk you through the process of creating one of these notebooks and using it to solve an interesting problem. So that's linked to in the slides, and the actual code lab is prototyping models in AI platform notebooks. So give that a look if you're interested. Features, it's also managed by Google, one-click deploy. It's backed by a pretty powerful virtual machine, which we call the deep learning virtual machine. As I showed you, you have lots of control over the resources, well integrated with Google Cloud and GitHub. This is really production oriented now. You can run CI pipelines, get logging, and do source control. One of the really cool things is it has automation built into it with a Notebooks API. So if you wanted to write code that would automate some or put something into a continuous deployment pipeline, you can use this Notebooks API to automate the creation of a new notebook, the loading of a notebook from some third-party source, execution of a notebook, manage the output of the notebook. So it gives you a lot of programmatic control over the notebook environment. And as I mentioned, the big win is the performance is not throttled. You have unlimited server lifetime and as much resources as you want to pay for. There's no cost directly for the notebooks, but any cloud services you use when the notebook is running, computing, storage, other features like BigQuery, etc., you will accrue charges for. But the notebook itself, as an entity, it doesn't have any particular cost associated with it. And there's a really nice link here, which is the pricing calculator. So if you ever feel bewildered by all the different capabilities in the cloud and how much you're going to pay for using anything, this is a nice resource I always point people to. So let's see if I can find AI platform is right there. So you click on that, and then it doesn't actually have a notebook option because, as I said, notebooks themselves are free. But if you ever wanted to figure out, what if I train a model in this AI platform, you can select the training tier, whether you're doing batch or online, and the total number of hours you expect to spend. And it'll give you an estimate of, say 10 hours. It'll give you an estimate of how much it'll cost you. So you'll usually find these prices are quite low, like 93 cents per month to do 10 hours of training, which isn't a lot of training time, but it's also not a lot of money. So I invite you to check out that resource to estimate your cost. Some of the limitations, there really aren't many. It's not free. I guess that's the main limitation, but it's not really a limitation. It's just something to be aware of. You do have a limited set of hardware options and kernels, but it's certainly more extensive than are available on the free services. So arguably that's more of a feature than a limitation, but just good to know about that. And this is great for actual commercial use. So if you're a company, a business professional, a researcher who really needs production quality, predictable performance, this is the option for you. I also feel like the source control and Git integration makes this much more amenable to engineering disciplines. And the customization is a huge win as well if you really need a particular type of environment, or for example, if you're an R person. This last slide, well, hopefully it's not exactly the last slide, but the summary, I guess, of everything I've shared with you today is, I won't repeat it, but I think it just captures everything in one place if you want to refer back to this as to what each platform is best made for. I've included a list of Jupyter ecosystem tools. I'm not going to have time to go through this, but I invite you to take a look if you're really interested in what sort of extensions you can bring to this environment, how you can enhance it with some open source tools. Each one here is linked, so you can find usually the GitHub repo for each of those. I also recently created a repo, which is a list of teaching tools in general. So not just GitHub, or rather not just Jupyter, but anything that I've stumbled upon or heard about that seems to be a good tool to know about, with links for teaching people. So take a look at that. If you know of something I'm missing, send me a pull request. And I just want to close by saying this is one of the things I like most about these notebooks is it makes a lower barrier to entry for people who aren't coming up through the normal route of computer science degree or what have you. And just as Tim Berners-Lee, who's pictured here, really focused on making the web something that everyone could access. I hope we continue to do that for other domains in computing. And that's one reason, as I said, why I think notebooks are great for getting other people on board. And I think that's it for my talk. Let me check and see if, yeah, it looks like I do have some questions.
Thanks a lot, Mark, for the session. It was indeed a great one. Now, let's have some questions so that Mark could answer them. Okay, so one question is from Akhil Tushar. Which notebook is better, like Colab or Jupyter or any other one?
So better is in the eye of the beholder, and it really depends on what problems you're trying to solve. As I mentioned, if you are using a notebook in a production data science kind of environment where your company is built on the notebook, I highly recommend AI platform notebooks. If you're an experimenter, a teacher, a student, Collab is great. If you really want to dive deeply into machine learning and AI and data science, there's nothing better than Kaggle as a resource for learning more. And I should add that, I have a Google bias because I work for Google and my job is to help people take advantage of Google, but there are other cloud services that you may have heard of, and they also have interesting notebook options. And so it's probably worth taking a look at everything that's out there if you're really interested in using this technology.
Amazingly answered. Okay, so another question just arrived. Which is better, TPU or GPU?
That's another one of those. It depends on what problem you're trying to solve. But GPUs were really designed as graphic accelerators, and TPUs were built right from the start to facilitate the kind of matrix multiplication and other computing operations that speed up deep neural networks and a few other machine learning techniques. That doesn't mean TPUs are better, but they do tend to outperform most of the traditional GPUs. They have configurations that scale up to incredibly high performance computing engines. But that said, there's a little bit of a arms race in this industry. Just like in the computing world, the GPU world is constantly coming out with more and more innovations. The other thing that's important, I think, to point out is TPU is a Google-specific technology. You can get access to a TPU in the Google Cloud, but you probably aren't going to see a TPU in one of our competitors' clouds, whereas the GPUs are more open industry standard devices. As a really rough rule, I think you'll get better performance with a TPU for the average problem, in quotes, but you have to decide if it's worth it for the trade-offs I just talked about.
Amazing. So the next question says that what things are available for free for students?
Well, there's always the whole G Suite thing, docs, drives, sheets, etc. But I think you're probably asking specifically in this domain. And the two options I mentioned that are available for free for students and teachers are Colab Notebooks and Kaggle Notebooks. Both of those are completely free of charge. I put a little asterisk next to Collab because there's an upgraded version of Collab called Collab Pro, which I mentioned and is talked about in the slides. But you don't have to subscribe to Collab Pro. You can use the base Collab. I use it all the time. I teach with it, and it's quite impressive and usable, and it's completely free. Same model as Google Docs.
Right. Again, the next question is there. 15 is the answer for the puzzle. So your puzzle is solved or not?
Yeah, and as I warned you, the answer, what looks like it's probably the obvious answer is not the correct answer. And the way you can tell that is it looks like each of these bubbles is the subtraction of the two pointing to it, right? So 27 is 99 minus 72, 18 is 45 minus 27. And that's, I think, where you got the 15, which is 36 minus 21. But if you keep going down here, let's imagine this is 15. 28 minus 15 is 13. So it's looking good. But when you get to the very bottom, 21 minus 13 is not 7. So that pattern breaks, and you have to go back and think about it a little bit more. It's a diabolical puzzle, but good, definitely a good guess.
Okay, so I think we need to try it more harder. So I think the questions have been asked by the viewers, but still some hackers might not have been able to join this session live. But as the recording is going to be available for all the others, if they will have any questions and they would like to ask, then we have a specific channel on Discord. So if you have time and if you feel that you want to see some of the questions, then you may look into that channel. And again, thanks a lot. But I have one more question from my end. So see, at Hack This Fall, there will be lots of different levels of hacker joining us. So do you have any tips or suggestions for them which you would like to give?
I missed a little bit of that. There will be a lot of questions about what?
Okay, so I was saying that some of the hackers might not have been able to join this session live, but as the recording is going to be available for others, they will be able to ask questions on Discord. There is a channel
Yes.
with a specific name to ask the speakers. So if you get time,
Oh, yeah.
please feel free to answer them.
Will do.
And yeah, one more question, which was from my end, is that at Hack This Fall, we are going to organize an hackathon. So there are different levels of hackers which are going to join us, right? So do you have any tips or suggestions for them which you would like to give?
That's a bit open-ended, but when I get this, sometimes I get this question: how can I learn about some very broad area like the cloud or machine learning or data science? And my best answer is to go with problem-driven learning, meaning rather than trying to learn everything there is to know about data science, for example, and sort of feeling like, okay, I have to read this book and I have to read that book before I can do anything. I would suggest just the opposite. Pick a small problem, but try to pick something you're really interested in solving, something that's going to kind of take you on a little bit of a journey, and then just learn enough to start making progress on that problem. And you'll feel uncomfortable because you'll feel like, well, I don't really know what I'm doing. I'm just copying things from Stack Overflow, and it just feels very confusing. But eventually, if you just continue and continue with that sort of a process, I think eventually you'll build up more knowledge and more confidence. And yeah, there's also a place for reading books and taking courses. I'm not discouraging that, but I really like getting started by picking a good problem domain and letting that propel you forward. So for the hackers and hackathons, hackathons are short. You don't have a lot of time. Pick something in the domain of the hackathon that really intrigues you and you're really motivated to solve, and then figure out what technologies you need to push that ahead.
Yeah, really fantastic thoughts and very valuable suggestion to all the speakers, and I hope it would be a great help for all the hackers. Thanks once again for joining us today. It was amazing hosting you, and we enjoyed the session personally as well. So
thanks so much for having me. It was my pleasure. Sorry about the glitches, but really enjoyed speaking with you today, and wish you a good day today for everyone.
So also guys, do fill the feedback form shared in the chat section, and it will also be used to assign the certificates for this particular session. It will be open only for 15 minutes and won't be reopened again. So don't forget to fill that form. Thanks a lot everyone who had joined us today, and don't forget to subscribe the channel so that you can get the updates for all the workshop coming up ahead. Stay tuned. Hope to see you in the next session. Stay safe. Take care.